Alrighty, I think I should be live now. Maybe. Alrighty. Check 1, 2. That should be live now, right? How do I get this thing to go unlisted? Or listed? One day I'll figure out all this live stream stuff. Oh, there's the public setting. Hi, Spike. Shit, okay, I think I actually have this thing working now. Cool, so my favorite toy in the world, this MP9 that I just seem to keep doing videos about. Still waiting parts to fix the gas part of this, but yeah, I figured I haven't seen a video talking about the Angry Gun suppressor tracer unit, and no one really does airsoft teardowns to kind of dig into the quality of gear. They just kind of talk about features and stuff. No one critiques build quality, no one critiques features and design methodology. So I figure I'm just going to keep doing that. For those that aren't familiar, this is the KWA MP9, and like the real thing, it's got this lovely tri-wing muzzle brake, and it lets you do that with a suppressor, which is fun to do. Just gonna put my video up on screen so I can actually see it. Output projector. There we go. Yeah, so you can quick detach this thing, and it's a solid tracer unit, but I figure why not actually tear into it? As a side note, if you get the CQB Master flash hider to try and use with it, the machining is not correct, and you have to do a bit of Dremel work. So I did a bit of Dremel work and polished it up just so it's not rough and doesn't damage things more. But now it finally fits, so be warned, it won't fit properly. You have to do some fiddling yourself. So on the outside, this suppressor is made of mostly aluminum, a couple small bits that are steel. You've got a lower Picatinny rail for mounting, I guess, an extra flashlight or something, because that's sure tactical and stealth when you're trying to use a suppressor, but sure, let's roll with it. This is airsoft and nothing has to make sense. Taking off the top portion, this is aluminum. At least it seems like aluminum. Could be hot metal, but I think it's aluminum. And I can't find my tweezers. Seeing a couple burrs here on the inside rim of this machined portion, as well as a bit that isn't deburred. So I guess this was machined out of a solid piece of aluminum, so I'll give them credit for that. They didn't finish the edges, so I mean, geez, it only takes a second with a little deburring tool just to take the edge off of that. Nope, it's a mock suppressor with a tracer unit. Someone in the chat was asking, hey, does this thing have baffles in it? No, it's airsoft. It's for fun. Next portion of this is a thin wall aluminum outer tube, and my batteries are almost dead in this thing. 1.9 mil thick aluminum, 1.7. It's probably 1.5 millimeters, but my calipers are catching some of the curvature of the wall. Okay, so 1.5 millimeter thickness, not bad. It should hold up to most abuse that an airsoft player can give it. And then you've got this portion, which is the actual part that connects to your tri-wing adapter. I did notice that when I was playing around with this, this portion can get unscrewed and loose. So I'm just going to dig into this and hopefully nothing falls loose here. Okay, so it looks like that bit's captive. So you've got the rear cap for the suppressor tube, also aluminum, also machined. Yeah, non-magnetic, so unless it's stainless, it's not going to be steel. And it's pretty light, too. And then you've got the actual part that fits into the muzzle device, the flash hider. There's a little O-ring here which seems to provide an interference fit. I guess on the actual MP9, the dimensions are a little bit different, and this O-ring helps, I guess, minimize vibration. But on this CQB Master flash hider, it's not even a friction fit. It won't decrease performance, but minor observation. Other than that, it looks like the spring-loaded latch device has a captive spring to it, so you're not going to lose anything if something becomes disassembled. And I'm not sure if the camera can see this inside, but you can just start to make out the moving pin that interfaces with the actual flash hider. Let's see if I can get this on camera. And tweak the focus a little. Yeah, so if I just get that, you can see it index in there. It seems to work alright. I mean, it's based off of the real design. Let's get that set back up correctly. So, the suppressor housing itself seems to be sturdily assembled. Not much you can really screw up with the suppressor housing other than making it too flimsily. Threads all have good fit. All the important parts are deburred, so you're not going to cut yourself on it. I might have to put some thread lock on this component just because it does seem to want to come loose and unscrewed. But that's enough about the suppressor housing itself. Let's talk about the tracer unit. This is the Acetec AT2000. You can get this in a couple different flavors. It comes with this machined, well, partially machined aluminum tube. It looks like the inner dimension is not machined, but they must have some degree of QC spec because it is a seamless tube. For those of you that are familiar with metalworking, when you order tubing, typically it comes with a seam welded down one side, and sometimes that seam can cause fitment issues or other things. They also machined the outer shoulder so it actually has a slip fit in with the suppressor. And this just helps guide BBs down the last little mile inside this assembly and keep the tracer unit itself aligned so it doesn't flop to the side and end up directing BBs into the housing itself. Nothing remarkable about this. I guess they must have broached the aluminum tube because there is no seam on the inside. But the outside is definitely just the mill finish. Digging into the suppressor itself, serial number 7050. I wonder if they actually do put serial numbers on there. It takes four AAA batteries, and power switch here. You can turn it on, turn it off. There's really only 2 settings to it, to my knowledge. Played a couple games with this. Interestingly enough, there's a 4-pin header connector here that if you have some kind of programming device, probably ICSP header of some sort, in-circuit system programming header, you can kind of modify and tweak it. There is a status LED that blinks every so often. Yeah, there it is. So you know when it's turned on, and then you just press it to turn it off. In terms of its actual functionality, there's 2 photo sensors in here that detects when a BB's traveling down its length, and it's designed so that you can flip this either way in your suppressor housing and it'll still work. So, yeah. What is this for? It's an Airsoft. It's an Airsoft accessory. Tracer BBs are phosphorescent BBs which glow, so you can use it in nighttime games or low light games and see where you're shooting. Only downside is that it works both ways, so you know other people know where you are. On the outside we've got a high voltage do not open warning. Yeah, to hell with that. I guess just to show that this thing works, I'm gonna turn off the light. That is very dark. There's a lot of light in this room. Open that up a little bit. I'm gonna turn the tracer unit on and just run a bunch of BBs through here, and hopefully they start glowing. So you can actually see the unit triggering every time a BB passes that photo sensor. And if I just dump the BBs out into a... Yeah, there we go. They kind of glow in the dark. They do decay pretty quickly. But again, when the flight time of the BB is measured in, I don't know, seconds to hundreds of milliseconds, it really shouldn't matter that they only glow in the dark for a very short period of time. Only downside of tracer BBs is it's harder to find bio-tracer BBs, and they're also more expensive, and if you get the red ones, they don't glow as strongly, and they're even more expensive. Alright, so let's take the batteries out and see how this thing's put together. Looks like we've got clamshell with 2 tabs. I don't think these tabs are pressure fit. You can't push in on these and bend these down. It looks like this just clamshells open because there's only 2 screws here. Just based on this side's the passive side of the battery compartment, just because these 2 are jumpered one to the other side. So let's find a torque screwdriver that works. Am I guessing right? It is, maybe? Oh yeah, it's definitely a T9. Okay. Let's use this T9 and open this. Now the important part of this exercise is they say it's high voltage, so let's not get shocked. If you've ever disassembled disposable film cameras, if you're a 90s kid and your parents wouldn't trust you with the, several $100 film camera, you got a disposable film camera, and these things were powered off of a single AA battery and had a boost converter inside, which took the 1.5 volts and stepped it up to, I would say, 200 to 300 volts. That would allow you to... Okay, so the screws are on this side, so it should clamshell open like... That was easy. Alright, so now first step, let's see what has voltage on it. We've got 2 capacitors. Get my trusty old fluke out. We've got a capacitor here that's marked 10 volts, so this is probably the side for the low side. This capacitor is marked 50 volts. So let's see what that is You know what? I don't feel like having this thing roll around on me, so let's just get that. Let's see if I can... Unfortunately, the other camera now can't see what's going on. Alright. Is there any residual power on this sucker? Okay, there's 30 some odd volts, and the other one should be nil because it's in... Yeah, okay, it's just decay voltage. That's fine, I should just be able to short this out with a screwdriver and... Okay, yeah, that's a dry polymer capacitor. It's got low series resistance. It's curious, though, why they need a capacitor for only 50 volts. So let's dig deeper into this, because I don't feel like getting zapped. That's discharged fully now, right? Yeah, okay, it's discharged. Let's zoom in and enhance. And let's aperture that down ever so slightly. Alright. So in terms of construction, it's pretty straightforward. We should just be able to push these two down and wiggle this free. It looks like there's two captive clips here, but that should be pretty straightforward. So let's just wiggle this guy free. Okay, the battery springs are free. So now maybe I can just slide it out this way and... Almost there. There's another plastic part here which is kind of interfering with its removal. Oh, maybe if I just... There we go, and it all comes apart. Okay. So plastic components first. We've got a plastic cover with... I'm going to snap this back together the way it was. Alright, we've got a plastic cover with two channels. Sorry, that's off camera. Two channels here and here for the photosensors to detect when the BB's passing through the center. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 holes here for, I guess, an array of LEDs, and that's about it. This plastic cover is held on with 4 spring clips, and then on the inside you've got a metal reflector to help keep the light inside. So I'm guessing these are violet or UV. Let's talk about the PCB. On the underside, the side that we can't see, we've got the switch, the status LED, and this status LED interacts with the... Wow, okay, that's actually some extra effort that they went through. The status LED, that little green LED over here, actually interfaces or touches to this extra piece of plastic. So this is a light pipe, and because that's pushed up against this LED, the light actually makes it all the way through the assembly. So I guess bonus points to them for that, because they could have made it cheaper and just not use that extra fraction of plastic, but they did the right job. Also kudos to hand assembly. This is something that's definitely hand assembly. There's a lot of hand assembly, come to think of it. So you've got the switch leads here, which actually are cut flush with side cutters. So a human actually had to go and snip each of these flush without damaging this little tiny surface mount 0603 LED. So definitely they put the extra effort in there. You've got 4 photosensors as well. Okay, 2 photosensors and 2, I'm guessing, IR LEDs. And then you've got the battery spring terminals that are soldered onto the board. On the underside, sorry, on the, I guess, top side that we saw earlier, you've got 3 Interesting. Programming headers. There's the 4-pin that we saw from the other side. Interesting. Is this USB? No, this can't be USB. Okay, interesting. So it looks like P3 and P2 are actually in parallel with the photo detectors. So I guess on the test bench they can actually hook this up to a test jig and inject signals to make sure that the board works. So they've designed QC into the PCB itself. And then this is the programming header. I don't see differential pairs, so this is probably not USB. You've got a tiny little ARM processor. That's really tiny. And you've got a couple extra test points here, P34, P35, charge and flash. So I'm guessing that they used a bed of pogo pins here to test the functioning of the PCB. Now let's work this out. When we opened this up, we measured 32 volts on this cap. If I were to power this up and actually bring it up to voltage, we could probably measure what its voltage was without the decay time, just because it took a couple minutes to actually open this up. But I'm guessing that violet LEDs are maybe going to be, let's look it up real quick. What's the forward voltage? Why bother looking up the forward voltage when you have a device that can measure diodes? Duh. Let's put that in picture. And let's measure the forward, not that way. Is the forward voltage too much for this thing to measure? It might be. Yeah, it's either that or it's conformally coded, and that's why I can't measure it. Maybe it's conformally coded and I just can't measure it. Is it conformally coded? Nah. That can't be conformally coded. I'm pushing down on this. Okay, so what are violet LED forward voltages like? Violet LEDs sit anywhere between 3 to 3.6 volts. So I guess the principle behind this is they charge up this capacitor to 30 to 36 volts probably, and then trigger using that MOSFET. So just looking at the circuit design here, and I wish I could zoom in a little more. It looks like you've got a small transistor here, and a small switch mode controller right here with a little flyback transformer to take the, 4 batteries, 6 volts DC all the way up to 30, so it's not that far of a stretch. It must be pretty efficient. And then you have this big MOSFET to discharge this capacitor through this string of LEDs. And actually, the execution of it's pretty good, because if you put these LEDs in parallel, you risk putting too much current through any one LED. But by doing these in series, right, you increase the voltage, but the current is still in the milliamps, and you can get a very quick turn on, turn off as soon as the cap runs out of voltage. So you don't ever risk blowing up one LED, and you don't ever risk, if one LED fails, that each other LED fails in series. If one LED fails, the whole string goes dead, effectively. If it fails in a conductive mode, then the other LEDs will get more voltage and probably fail as well. What do you think? Internal tracers that are made. Internal tracers like the Max Products tracer, they're okay, but they're not hugely efficient. You just run an LED all the time. If you go the effort of putting in a photo sensor, then maybe you can get better efficiency, but it's one LED versus this array of 10. By turning on all 10 of these at the same time as the BB passes through, you you get more illumination on the tracer. So I'm kind of on the fence about internal tracers. It does not look like this board was cleaned off during manufacture, because I see flux and rosin all over the place, just kind of flaking off as I poke at traces. Which also means that this board is not conformally coated, so that's a minus to Ace Tech. You know, you play Airsoft, you know, you'd expect to be playing in conditions where it may be raining. A lot of MOSFETs, or like MOSFET boards, such as the Gate Warfet, the Titan, the HPA engine controllers for the Wolverine MTW type stuff, it's all conformally coated. It's all expected to get wet. So why wouldn't Ace Tech conformally coat this? It takes very little effort to conformally coat a batch of boards all at once they've passed QC. So that's disappointing to see. This board required a lot of hand assembly, though, because surface mount manufacturing, typically you only want components on one side. Gravity holds the part in place. Say this is a direction of gravity. You apply solder paste, you apply components on top, and they sit on top. They run through the reflow oven. If you have surface mount components on both sides, right, you have to glue the components on with extra adhesive so that they don't fall off when they go through the reflow oven. So the fact that there's surface mount components on both sides means that, relatively speaking, per square inch, this is an expensive board. And then they've got through-hole components on both sides, because they've got through-hole components on this side, and they've got through-hole components on this side. Because they've got surface mount components on both sides, that means that they can't do wave flow soldering, where they basically have a small pump that pumps molten solder into a little trough, and then this board rides over the trough, covering all the pins. These are all hand assembled. There's no way to get around it. They populate all the components on one side, possibly both, that are surface mount, and then they hand assemble the rest. So yeah, this is an expensive board in the grand scheme of things. So I can get why they wanted to cut corners a little bit. Regardless of that, let's try and test this thing without giving ourselves a zap. Let me just get my power supply here, turn the current down. Let's see, current voltage. Voltage down to 6 volts. Sorry guys, this power supply is a little finicky, so you just gotta get it dialed in just so. Alright, 6 volts, let's power this thing up on the bench. Okay, I got a bit of a spaghetti going on. Let's not lose those components. Alright, so we got ground, we got VBAT. So that's ground. And let's turn the current down a hint. Alright, there was a small surge of current going into the board when I turned it on, or connected it to power, so it looks like, interesting. It doesn't look like this capacitor is in parallel with the voltage input. It has to go through that little transistor Q7. Regardless, let's turn this thing on, so it's on now, and it's not really taking any current, but if I... oh wait, no, it's not on. Now it's on. Oh yeah, there we go. Oh, interesting. it has a failure mode. So if you trigger it too many times, it blinks red. So this is actually a double LED. Yeah, there's two sets of traces. This is a red-green bicolor LED. And there is an error indicator on this thing. Regardless of that, let's see what voltage is encountered here when it is on and running. Yeah, okay, so that's running. Let's not spark this up. Wow. I didn't expect that. And I didn't believe... You're not going to believe this, so I'm going to have to put this on camera. $64 volts. 64 volts. What the fuck? Let's discharge that. Alright, there we go. So, here's where I'm a little pissed off at Ace Tech. See that? See that little stamp there on the capacitor? That is a 50 volt rated capacitor. Why am I seeing 64 volts on a 50 volt rated capacitor? This is going to fail. That is just disappointing to see. That is buffing compound on my thing now. Wow, okay, that's really disappointing to see in Ace Tech. I'm gonna write them and see what they say about that. But, yeah, to hell with warranty void if open. It just says do not open for high voltage. It doesn't say anything about warranty. Yeah. Why are they putting 64 volts on a 50 volt rated capacitor? That is not going to last forever. I'm gonna have to order some... I'm gonna have to order a replacement from DigiKey and spec it for like 100 volts. Typically, when you design a system and you select capacitors, you have to think about its effective current draw. If you're using it to handle small amounts of ripple current, then you can underspec it in terms of its equivalent series resistance, its ESR. You don't have to have a very low ESR to handle very minimal ripple current smoothing. If you have a very high ripple current because you've got a big current draw and it's not a steady current draw, it's noisy, then you need something with a very low ESR, like a polymer cap like this guy. Regardless of that, if you underspec the capacitor, eventually the dielectric is going to fail, and then the capacitor is going to fail in a short. In this case, because the system's so low powered, it's not really consequential, but it's still going to fail. So, is this just cutting corners, or is this just, bad selection? I mean, if you've got a high ripple current device, and you're rated at 9 volts, and you never expect it to ever, in any failure mode, be over 9 volts, then sure, this 10 volt, input smoothing capacitor is totally acceptable. So this one's fine, right? 1000 UF at 10 volts to smooth out the 6 volt input here, because these little AA batteries aren't going to be able to keep up with the boost converter charging up this big polymer cap when you're shooting high rate per second BBs through this thing, right? I mean, like, when I had this thing turned on and I was just tricking the photosensor into going off, you could see how fast it was triggering. It had no problem up to a certain point. But the fact that they underspec this is actually kind of infuriating. So we will see what Ace Tech says about that. Okay, I've basically torn this thing right down to nuts and bolts, as far as I can really go. So I'm going to just start reassembling this. Yeah, I can't really think of any other critique to give this. It's a solid design. I'd appreciate if it was conformal coated, and I'd definitely appreciate if they didn't willingly underspec this capacitor, because that's the most important frickin' part of this whole thing. What is this? This is C2. This is the second, this is C1, so this is the first capacitor they thought of when designing the board layout, and this is C2. This is the second capacitor they thought about. So, I'd expect them to do better, but apparently they didn't. So we'll see what Ace Tech says, and if they give me a meaningful response, I'll post it online and see how they respond to that. Alright, so I think that's about it for this video. I've been going for, what, like an hour now? I've been going for 36 minutes only. Okay, cool. Well, there's not much more to this, so I'm just going to keep thinking of Airsoft teardown videos and things that are cool and relevant for Airsofters, because I hate having to sort through all these reviews which talk about playstyle and feel and qualitatives, and we don't talk about the quantitative. We don't talk about the material of construction, we don't talk about the design, you know, we don't actually talk about, is it a good quality product worth my dollar? Because, let's face it, my salary's not getting any higher, and a lot of Airsofters have to kind of work on a budget, so, you know, they won't be happy to find out that parts are under-spec by design, not to fail per se, but to save a couple pennies, and if and when it fails, they're going to have to get a replacement if they don't know any better to replace that single capacitor. Yeah, alright, I think that's it for me, so stay safe out there. Oh, was I able to find steel internal MP9 parts? No, because no one makes steel internal MP9 parts that are aftermarket. I'd have to design and get them machined, which right now I just do not have the time for. Yeah, it's unfortunate that no one does make them, but I can only fight so many battles at a time, and getting steel components for the bolt carrier and everything else in my airsoft gun are just not a priority. Man, this is a fiddly reassembly process, because you have to, like, thread the frickin' needle here to reassemble this. Did I make a mistake opening this up this much? Alright, so this side stays clipped in. You know, I'm just going to keep the camera running just to see how tragic my reassembly attempts go. So I gotta spread that out. Maybe if I do that? No. Maybe I have to put this in first. You know, all it takes is someone to just go and design the parts. It's probably not worth the effort of the major aftermarket airsoft part manufacturers to design these, just because it's a relatively small market. Like, if you're a company that's paying people a salary to sit there and design parts to fit into airsoft guns that are aftermarket, not aftermarket airsoft guns, but, you know, Marui spec airsoft guns, wow, that is a very fiddly assembly. So this whole process, oh, I forgot to put the other bit in. God damn it. So I gotta get these two tabs in. Ew, that is... It is a compact and space-efficient design. That's all I can really say. The physical design is good. It's just, there's polish and other stuff that could be better. You know, even the, this component here is designed to not flake out, I guess. Is that all correct? Yeah, I guess it is. The LEDs all line up on the inside. Yeah, if you're gonna pay someone a salary to design parts, you're gonna have them design like the most popular parts for like M9, Glock, 1911 high kappas, You're going to have them design parts for M4s, right? It's a business decision, really. Unfortunate to say it, but that's really what it boils down to. So you really have to have an enthusiast want to pursue designing and manufacturing aftermarket high-quality steel internals for the MP9 before that ever happens. And, you know, maybe there is a market for it. Honestly, if I ever design more parts for the MP9, it's just going to be because I want better stuff for myself. And if I can make a buck buck off of it to support my hobby, then all the better. So let's put that in there. Batteries. Let's put that there. Put that there, and then it turns on, and no, it was off. Yep, it works. Cool. Now I'm going to take the batteries off and put it into storage, because I don't know when airsoft fields are going to open up, and I'd rather not have batteries leak all over my nice tracer unit. It's a bit of a shame to see the... maybe I did this on... Look at that. I guess during assembly I was a little bit ham-handed, and this plastic cracked right here. So yeah, that's probably my fault for being ham-handed during assembly. But oops. Oopsie doopsie, I made a fucky wucky. It still works, that's all that's important. I will have to contact Angry Gun, not Angry Gun. Angry Gun just made the housing. Angry Gun made the housing, Ace Tech made the tracer unit. Ace Tech's the one that's going to have to answer for under-speccing a part. Yeah, seeing 65 volts on that capacitor when it's only rated for 50 is pretty blatant. Yeah. Okay, cool. I think that's the video. So stay safe and have a good one out there, folks. Peace.